In section 4, we're going to be solving special systems. So, before we get into vocabulary and things like that, that's later on, we're going to start with actually just doing a couple of examples. So, the first thing we're going to do is solve this system by graphing. And if this goes out and we are still on the school closure, which I don't know if we will be, I'm recording this on Tuesday the 24th of March. I'm going to tell you to use Desmos if we're still out to do your graphing. So, on your iPads, we open up Desmos. And think about it for a second. Now, let's see, we're asked to graph y equals x minus 1, y equals x minus 1, and we're all, too much. Also has to graph negative x plus y equals 2. So negative x plus y equals 2. How about if I put those on two separate things? Yes, negative x plus y equals 2. There we go. So when we graph these, you should notice we've got parallel lines. Okay, they have the same slope, which is 1. They both go up 1, right 1, up 1, right 1, up 1, right 1, forever and ever. And they have different y-intercepts. The first has an intercept at negative 1, and the second has an intercept at positive 2. So, parallel lines. What's that mean? Let me get the notes back. So, parallel lines with different y-intercepts means they don't intersect. And if you don't intersect, there's no solution to the system. Okay. Algebraically, what would that mean? Because you're not going to be able to graph all these guys. There will be problems I mandate that you solve using elimination and substitution. So, we need to, first I need to turn off autosave. No, turn off. Thank you. And let's see, I need to write these down because I'm going to lose them. That is my dog having a whine because she wants me to pay attention to her and not record a video. Sorry, Lex, I have to do my job. Alright, so let me slide this up so I've got room to work. This system is meant to be solved using substitution. I know that because one of the statements has y equals. So in the second equation of negative x plus y, instead of plus y, I'm going to put plus x minus 1 equals 2. I'm going to substitute. Combine my like terms, which are those two right there. Negative x plus x cancels. It's 0. So negative 1 equals 2. That, my friends, is what we would say is not true. And when you get a false statement, your system has no solutions. Okay. And that's right here. So, solve by graphing. So, pop back over to Desmos, clear this stuff out. Bye-bye. And let's see, we have y equals 2x plus 1. Y equals 2x plus 1. And we also have 2x minus y. 2x minus y plus 1 equals 0. Oh! So the red line is the original one, and when I complete this equation, I get a green line that is right on top of it. That's not a coincidence. Okay. The lines are exactly the same. In slope-intercept form, the equations would both read y equals 2x plus 1. They're the same. Which means that there's a whole bunch of ordered pairs that will work. Not every ordered pair, for the record, but every ordered pair on the line would solve the system. There's no way we could ever list all of them, so there are infinitely many solutions. So let's see what happens to that when we use algebra. So again, I'm going to copy the equations, and this is again set up for substitution. I know that because one of my equations says variable, in this case y equals. So I'm going to rewrite the equation that doesn't say y equals 2x minus y. Instead of y, we have 2x plus 1. And yes, that has to go in parentheses. There's a reason for that. Distribute the negative sign, which means if it was positive, and they become negative. Combine your like terms. Now, here's a pair that cancels out. And there's a pair that cancels out. We get 0 equals 0. That is, of course, true. And true means there are infinitely many solutions. Okay? Infinitely many solutions. The other new bit for what we're doing today is classifying. Okay, so we've got some vocabulary here. Consistent simply means there are solutions. So if you get a single ordered pair, or you say infinitely many solutions, then you're telling me you're a consistent system. There are solutions. Inconsistent means no solutions. That only happens when you get a false statement algebraically or you have parallel lines. Okay? Independent is paired with consistent. Okay? Consistent needs a second word to describe it because consistent says one or more solutions. We need to know, is it one or is it more? So if we say consistent and independent, we're saying one, exactly one. If we say consistent dependent, we're saying one, not one, infinitely many. We're saying it's the more solutions. Okay? And you can see we classify using either consistent and independent for one solution, consistent and dependent for infinitely many solutions, and inconsistent for no solutions. And we can do this straight away out of slope-intercept form because if you're parallel, your slopes are the same, so long as you have a different y-intercept. If you have infinitely many solutions, then you are parallel and with the same y-intercept. And if you have different slopes, you will intersect at least once. So, classify each system, state the number of solutions. Ideally, what we want to do, okay, since we're just classifying here, is use that idea about slope-intercept form. So I'm going to take both these equations and put them in slope-intercept form. So for the top equation, which I'll do in green, I'm going to divide everything by 2. That gets me y equals 1/2 x plus 1. For the bottom equation, which I'll do in whatever this color is, reddish, yeah, it's mostly red, I'm going to add a half x to each side. So I get y equals 1/2 x plus 1. Those are the exact same equation, which means there are infinitely many solutions. So in terms of classifying, it is consistent because it has solutions, and dependent because it has infinitely many. Okay. For this next example, all I need to do is distribute here so that I have both equations in slope-intercept form. Because the bottom equation is already in slope-intercept form. So the first equation truly has a slope of 2. The bottom equation has a slope of 1. Different slopes means they intersect once, guaranteed. And that's all I'm asked to do here. I'm not asked to solve, I'm asked to classify. So, different slopes, that means they touch once. That means they are consistent and independent. Okay. And, oh yeah, this is all I got. Cool. So, get my pen back. Again, I want slope-intercept form. Hey, now, that's not cool. Oh, are we going to be doing this nonsense again where we jump? And my whining dog is back. Access. Come here. Come here. Relax. Relax. So my top equation, I'm actually probably going to need to do the work for these ones. So I'm going to subtract x from both sides to get 2y equals negative x minus 4. I'll divide both sides by 2, which means dividing everything by 2, to get y equals negative 1/2 x minus 2. Oh, for the love of all things, this is going to get annoying. I'm sorry, I really don't know how to keep it from doing that. But it will occasionally just decide it has to jump up. So I apologize. I don't know how to keep it from freaking out. The bottom equation, which is this guy, so I could distribute. I'm not going to. I'm going to divide both sides by negative 2 to begin with, so that I get y plus 2 equals negative 1/2 x, and then I will subtract 2, so that I get y equals negative 1/2 x minus 2. So here's equation 1, here's equation 2. Strike that, reverse it. And they're the same. Okay, they are the same. Which means, since they are exactly the same, that there are infinitely many solutions. Which make this system consistent and dependent. Again, I don't know why it's jumping like that. It's doing it without my input. Believe me, right now my hand is nowhere near the screen. So we have in the next equation y equals negative 2x plus 2 if I distribute, and y equals negative x plus 3. Well, negative 2 and negative 1 aren't the same thing. So different slopes mean they're consistent and independent because there's only one solution. I knew you were going to do that. And finally, this guy, the bottom equation is already slope-intercept form. So I just have to take this equation and put them in slope-intercept form so I can compare my slopes. So I'll subtract 2x, negative 3y equals negative 2x plus 6. Divide everything by negative 3. Y equals positive 2/3 x minus 2. Same slope, 2/3 x, 2/3. Seriously, quit doing that. But this has a y-intercept of 0 because it's not even written. And this has a y-intercept of negative 2, different y-intercepts. That means they are parallel. And that means there's no solution. And that means they are inconsistent.